Hello everybody, my name is Jim Pingle and welcome to our April 2017 Hangout. This month we're talking about Let's Encrypt and using our Acme package on pfSense. A little overview of what will be going over this month. First up we have project news as always, and then we'll talk about the basics of Let's Encrypt, how Let's Encrypt works, why you would want to use it, some limitations it has, talk about its validation methods, and then about our Acme package, some info about the package, how to make keys and certificates, and how to validate using it. We'll talk a little bit about how you might set up a DNS server to use one of the DNS update methods, or how you may have to set up your domain records for it. And then we'll talk about how you go about actually using the certificates that you get from Let's Encrypt. For the firewall GUI or with packages or other places on the firewall services and whatnot. All right. Well, for our April project news, we got a few things here. First, we're working on our 2.3.4 release. We're going to have that coming up pretty soon, probably next week if it clears our testing in time. This is mostly security and errata fixes and a couple of new features and some beneficial things, but enough that we felt it warranted another point release versus instead of going with another patch release. There's also a fix in there for the certificate handling in Chrome 58. They put in a new restriction. Well, actually, it's an old restriction, but they're actually enforcing it now, where they require the certificate to have the host name in the subject alternative name instead of just in the common name. So they pretty much ignore the common name and just use the list of hosts from the SANs. So in our old self-signed certificates, we're not made that way. So we put in a fix for that. So if you're not going to use Let's Encrypt, which we're going to go over this month here, and you intend to use self-signed, you might have to, after you update to 2.3.4, generate yourself a new self-signed certificate. There's a patch out there that we've posted on the forum and Reddit and on Redmine if you want to get that fixed sooner, if you need it. Other browsers are still working just fine. It's just Chrome's being picky about that certificate a little bit more than others. Our translation effort is still progressing pretty well. We've added several more languages to 2.4 that cross the 75% barrier. So 2.4 now includes Chinese, which is simplified, and also Taiwan, formal Norwegian, there's Spanish, Russian, and German. And I think almost all those are 100% except German's maybe in the 70s, or like 76, 77%, somewhere around there. But it's progressing pretty well. And if you want to help with translations, you can get yourself an extra year of pfSense Gold or a free SG-1000, depending on how much you contribute to a given language. So you can check out the blog post I've got linked there if you're interested in helping out translations. Our Shurikata package was updated to 3.2.1, and now it's got hyperscan support. There's a lot of people waiting on that. Our SG-1000 unit, we now have a DIN rail mount for that if you want to mount it like that on a DIN rail in a data center. We put up an article on April 1st about building a behemoth router because we're working toward 40 gig per second IPsec, gigabit per second IPsec. We put it out on April 1st, so people thought it was an April Fool's joke. We kind of got a laugh out of that, but it's actually a real effort, and you can read that post if you want to follow that link. We've also loaded an early build of what will eventually become pfSense 3.0 on there, and we have managed so far over 30 gigabit per second out of it, so it's moving along pretty fast. So you can check that Twitter post out with that too. I was also on Twitter. Jim Thompson has posted a little tease of one of our other new platforms that are coming up, so check that out. We'll have some more public information about that pretty soon. We do have training in Paris, London, Frankfurt, and St. Petersburg coming up, so go to netgate.com/training if you're interested in signing up for one of those classes. We've got a new AWS pricing structure up, including a T2 Nano instance that's only $0.01 an hour. There's a link there to all of our Amazon offerings. On Azure, we now have a free tier. It's an A1/standard. It's a single core instance. It has no cost from us. There are still, I think, some Azure infrastructure costs, so you might have to, there's still a little bit of cost to it, but it's just the standard Azure costs, nothing added from us. All right, so a little bit about Let's Encrypt. Let's Encrypt is an open and free automated certificate authority from the Internet Security Research Group, or ISRG. Its goal is to encrypt the web, so basically get everybody to use HTTPS instead of HTTP. And it intends to do that by removing the cost barrier and some of the technical barriers that discourage administrators and organizations from obtaining certificates. So mostly web servers are talking about, but other ones too, like SMTP and whatnot. Now, there's a lot of red tape with getting certificates right now. Obviously there's cost and there's going through all the validation procedures and everything, and depending on who you're working with, it's more or less difficult to automate. So that's one of the things that we're looking to do, is just get it to a point where it's not an afterthought. It's just something you can easily set up and automate, and you don't have to worry about it too much. Most of the browsers out there, at least the current versions or recent versions from last, I can't remember when they got in there, but it's been a while. So current versions of all the browsers, major browsers, should support Let's Encrypt already. So you don't have to import or do anything or manually trust anything on the clients. And those certificates can be used for web servers like TLS or HTTPS, SMTP servers, IMAP and POP3, similar roles like that, which utilize the same type of TLS server certificates. So pretty much anything where you're providing a service to the public that can benefit from TLS can use one of those certificates. The certificates from Let's Encrypt are domain validated. So that validation ensures that whatever is requesting this, the Acme client, whatever, has authority over that server. It controls that server, or it controls the domain, the entire domain. So you validate that by proving ownership of the DNS records, or by hosting a file on the web server for the domain, and that lets it verify that you actually do that. And that's a pretty common, at least the web server part I've run into before. When I was trying to get a certificate before Let's Encrypt was around, I just had to drop a file with a certain name on my web server in a certain spot, and then they requested it, and it was just a method of domain validation. Pretty straightforward stuff. One thing that's different versus other CAs, Let's Encrypt certificates are only valid for 90 days. You might have seen certificates that are valid for a year or two in some cases, which, is convenient for setup because you don't have to touch it for a long time. But on the flip side of that, it's not very secure because, if something happens to that certificate, it's still valid for years. So Let's Encrypt certificates are valid for 90 days, and they can be renewed before that. So, the client will try to renew it every 60 days, which is the recommended time frame that Let's Encrypt wants you to do it at. And ideally, it happens all automatically. So automation helps that a lot. Your client will renew the certificate and then restart the web server. You never really have to think about it; just sort of all happens behind the scenes, rather than having to go into a panic once a year when trying to remember. Okay, well, how do I renew this? What do I have to go through? Do I got to pay him again? Do I have to do this? Do I have to? Okay, now where do I put these certificates? So if you do something more often too, it's gonna be easier to retain that knowledge than it's less likely to be forgotten than it would be if you had to do it once a year. The updates to Let's Encrypt, these validations and every certificate issuing and everything else, it's all managed through the Acme protocol, which is Automatic Certificate Management Environment, and that's where our Acme package gets its name, because it deals with Acme, and it's also based on an Acme shell script from I can't remember off the top of my head who makes that. I thought I had a note in here and didn't have it. So these certificates can cover many domains, subdomains, or host names. You can have up to 100 host names in a certificate. They don't all have to be from the same domain either. You could have 100 different names or 100 different host names from 100 different domains if you want. There's two signing structures available from Let's Encrypt. The first is a staging or testing certificate authority, and that's what you want to use when you're testing or getting familiar with the package. Basically, when you're not 100% sure how the validation works and you're just trying to get all the kinks worked out, do it against the staging CA. And that staging CA is not trusted by browsers, but it doesn't have any rate limits, so you can hit it all day with tests from your client, and it's not going to hurt anything. And then once you've got it working and you know those settings work, then you can try it against the production certificate authority with all your same settings. And that production CA is trusted by browsers, but it does have rate limits. And I'll go over what those rate limits are here in a moment. So the actual nuts and bolts of how this whole validation thing works. So you have your client, like the Acme package on pfSense or CertBot, or which is the client that Let's Encrypt recommends, or there's dozens of other clients out there for different operating systems and whatnot. So that client generates a key pair, and then it registers that identity with the Let's Encrypt server, and that gets registered against either the staging server or the production server. So then that client attempts to prove ownership of the domain using one of those validation methods we talked about. The Let's Encrypt will provide a set of challenges. So basically, the client tells Let's Encrypt, I want to update, or I want to validate this way. And Let's Encrypt says, okay, well, here's a bunch of challenges and a nonce, or just a one-time use random number. And then you need to meet these challenges, sign them using your private key, and then place them, wherever your update or wherever your validation method says to do it. And then the client will set all those files up. It'll either set up your DNS record, it'll set up your response file for the web server, whatever. And then it says, okay, I'm ready, basically. And then Let's Encrypt verifies that. And then so it'll either try to request that file, it'll try to look up that DNS record, whatever. And then if everything checks out, the client, Let's Encrypt says, okay, you're authorized. I trust you now. And then the client can perform operations like issuing a new certificate for that domain, or anything that's listed in the SAN for that certificate, renew the existing certificate, or it can revoke a certificate. So whenever you're doing this, every domain in a certificate, every host name has to be validated individually. So yeah, it can be, the more you have, the longer it's going to take, but it's pretty slick once it's all up and working. So, it's a lot of hoops to jump through. Why would you even want to bother with that? Well, it's free, it's easily automated, it's pretty useful. And then once it's set up, you just have to get over that initial setup hurdle. And after that, it's pretty easy. You don't really have to think about it at all. Obviously, HTTPS is more secure than HTTP. And browsers are complaining more and more about self-signed certificates. It's really annoying and increasingly difficult to use them. And if you don't use HTTPS, well, it's awful. But the warnings for that are even more prominent now. So I've got some other browsers I've got hanging around here. Like Opera doesn't do too much. It has a little window that comes up. Let me see if I can get it to do that. It may not, since I've already got it open in this tab here. No, I've already got it open. It just gives you a little dialog box and has you click through it. But it doesn't warn you too much. It just says unprotected, and it just kind of sits there and it's kind of blah. Now, if we look at Chrome, it gives you this big warning here: connection's not private, certificate authority invalid. Or you can view the certificate to look for some info, or you can get by it by clicking advanced and then clicking proceed. But once you do that, it shows not secure up here. HTTPS is crossed out. I think this looks a little weird because I'm in incognito mode here, but it's usually red and kind of scary looking. It disables autocomplete, so it's really not great. So I mean, it's a lot to click through, and it's kind of annoying, and you have to do that every time you go to load the page. Firefox is similar. You'll get this nice scary warning here: your connection's not secure. You can go to advanced, it gives you a little bit of info there. You can, if you add an exception, you can view the certificate and see, what's going on there. Like you can see it's valid for this host name, whatever. So Firefox, unlike Chrome, lets you permanently store the exception. So it's not as annoying there, but it still will whine a little bit about it being there. So let me add that that exception here, and you can see it's still got, connection not secure, and it's got a little bit of a warning. Edge, similarly, you have to click through, and it shows you certificate error. Not quite as annoying here, which is almost scary, but then it says certificate error. You should close the site immediately. Well, they didn't tell you that before you click through to get to the site, so So when you use Let's Encrypt, you'll get around all of that. You don't have to worry about that, and I'll show you how that works. We're going to set this particular VM up for it by the end of the Hangout, so pretty simple. So in addition to all that, you also have that uh, bug I mentioned, or not really a bug, that issue I mentioned during the project notes that we put a fix in for, where Chrome 58, and I guess Firefox 48 is also doing it too. They require that stricter formatting where they ignore the common name and use only the subject alternative names. When they do that, so you might need a new self-signed certificate. And not just for pfSense, but for other devices as well. If they generated a certificate that same way, they need to update it, or you'll have to make your own, and that meets the new standards. So, and through all that, especially with ones like Chrome and Edge that make you click through that warning every time, if you condition your users or administrators to get used to that and click through the warnings, they may never know if something is wrong. If something changed that wasn't supposed to change, they may never know. They just say, oh, it's a warning. I always click through that. And yeah, you can tell them, they need to be verifying all the certificate details every time, but who's going to really do that realistically on an ongoing basis? Sorry, I had to cough there. And you can get cheap certificates from other sources. I think there's another place that lets them, that has them for free, at least for the first year. There are some places where you can get them for like $10 a year. It's not too bad. It's not awful, but you still have restrictions on those. You still have to prove your domain ownership in some way. You would probably need an individual certificate for every firewall or service you want to use it for, unless multiple things on one are on one server. Okay, if you need to have SANs, that's going to probably increase your cost significantly. Sometimes they charge quite a bit more to have one certificate with multiple names. They may let you have like the domain name and then www dot the domain name, but if you want to have 2 or 3 other names on there, it's going to cost you. Um, we can get wildcard certificates to work for everything in your domain, but they're kind of expensive and they don't work with subdomains. So they've got their own set of limitations. You can use them, but you're be prepared again to shell out and also work within their limits. You could make your own internal certificate authority, and then create your own certificate signed by that certificate authority, but it's not going to have a chain of trust, to be fully trusted everywhere, unless you import that CA into every browser operating system device that you have on your network, which is a management nightmare. It's possible, yes, but there's a lot of overhead there. So there are a few things that Let's Encrypt can't do. First off, it does not support organization validation or extended validation certificates. Usually that's what gets your a little bit stronger validation, a little bit more customer confidence in your site being secure. It might different browsers display them differently, but it's what you see when like the organization name or whatever shows up in the address bar in the green area by the padlock. It gives customers an extra warmer and extra fuzzier feeling than usual. Let's Encrypt won't do wildcard certificates. Let's Encrypt will not validate a bare IP address or a short host name, so it's got to be a fully qualified domain name only. So you can't use that to you can't use it to get a certificate just for an IP address. Certificates are not usable for email content encryption or code signing, so you can't use them like you would say a PGP key or SMIME key or certificate. But they can be used for TLS mail access and transport. So like SMTPS.TLS, sure. IMAP secure, sure. POP3 secure, sure. You can use it for those, like postfix, dovecot, that kind of stuff. But you just can't use it to actually encrypt the message body like SMIME. All right, here's the rate limits you might run into with Let's Encrypt, and this is kind of a sticking point for a couple, couple things depending on how many boxes you've got. You can do 20 new certificates per registered domain per week. So if you have everything under one domain name, you could only register 20 new certificates for that domain per week. That doesn't count renewals, so renewals are always okay. It's kind of a rolling date, so if you did like 10 today and 10 2 days from now, a week from tomorrow, you could do 10 more, that kind of a thing. So you can grow that list over time. There's no total maximum limit. It's just this weekly limit you have to work under. So you can grow that list over time. And you can use SANS to work around that limit in some cases if you have a lot of, say you've got, 50 names on one server all under the same web server. You could do it that way, with SANS, where it could do all of those names in one certificate, and then that would only be one certificate against that limit of 20. So between there's a limit of 100 SANS per certificate. So between certs and SANS, you could get as many as 2,000 domain names per week, or 2,000 names under one domain per week, if you needed to. But in practice, you can't really make that work for the kind of things you'd want to get around that limit for. So, if you had 30 firewalls, you wouldn't want to try to share a certificate between two different firewalls. So you'd actually have to, maybe do either separate domain names or, get them going like 10 every few days, and then eventually the limits will be passed. Let's see here. You can do 5 duplicate certificates per week, which means, if you have to reissue an identical certificate, and that's by identical, it means the list of host names in the SAN is 100% the same. You can only issue 5 duplicates per week. There are 5 validation failures per account per host name per hour. And this one here is one of the reasons why you really want to use the staging server. If you don't have your validation settings right, and you're trying to dial it in and make sure you're working, like, not only that your site is set up right, but also like your firewall rules to let them through are okay, or your web server setup is right, whatever, you could hit that very easily. And yeah, you could go through and wait an hour and try again, but it's kind of annoying, and you may as well just use the staging server to test it out. And then once it works, use the real one. And there's some more rate limits beyond those. You can go to the Let's Encrypt org site and check that out. It's let'sencrypt.org/docs/rate-limits, and there's a whole listing there of all the different rate limits you might hit. Another limitation is that you don't know the Let's Encrypt servers beforehand, so you can't craft limited or dynamic rules. So you can't say just let Let's Encrypt hit your web server on your firewall, because you don't know where they're coming from. And that's kind of a security measure, because if you were able to predict where Let's Encrypt was going to hit your system from, it's possible that somebody could redirect that away because of the known source, and then use that to their advantage and validate something under your domain when they shouldn't be able to. And because everybody else in the entire internet doesn't get that same redirect, you may never know. So it's just another additional security measure. All right, so a little bit more about how you validate the domains, validate your ownership anyway. Use what we call challenge validation methods. So it's just a method that between the client and Let's Encrypt, it's a method where they can agree on how to exchange this information. So the first one is this HTTP-L1. And in using this kind of a validation method, Let's Encrypt will request a file from that location, /well-known/acme-validation on your target server. The actual target server is determined by the host name in the certificate. So every one of those host names in that certificate has to exist in DNS, and the Let's Encrypt has to be able to resolve them, and it has to be able to contact the web server on port 80 for all of them. So the name of the file in that directory and the contents of that file are part of the challenge that gets negotiated between the client and Let's Encrypt. So you can't really predict what the name or the contents will be, so that's all part of what the client has to be able to write out. So the client has to be able to actually place that file in that directory, as during the negotiation. So as I mentioned, each host name in that certificate request, so every name, SAN, whatever, will be challenged individually, and they must all be able to respond to the request. So, it can't just validate one name and then just assume the rest are okay. It's got to test them all. So every SAN has to have a valid public DNS record, so an A or a quad A. Requires external inbound connectivity so Let's Encrypt can request the file via HTTP. So again, that means you have to be letting them through the firewall. So the public has to be able to reach this web server. And you could redirect that to another port. Let's Encrypt has to hit port 80, but you could uh, locally have that listening on another port, and then a NAT roll forwards it from external port 80 to some other internal port. So, as long as Let's Encrypt can place those files wherever it's going. So you could say use a method where, the client can, put files on a web server with FTP or I mean SFTP, and it'll place those files on that web server, local web server that's off the firewall, and then Let's Encrypt can come through, hit the NAT rule, and hit that other server. And as I mentioned, HTTP validation must use port 80, no exceptions. It has to use port 80 because if you could use arbitrary or high ports, then somebody could run a second web server on there, and so they could again validate for a server they don't have full control over, or they're not supposed to be able to control. So it's an additional security measure. And then let's see, the next method we have here is TLS SNIO2, which is sort of a cousin of HTTP01. It works exactly like HTTP, except it uses TLS, like HTTPS. It requires the server to support SNI, which is basically a fancy way of saying virtual host for HTTPS. The client will request a specific server name instance, and the server will only serve files from that particular host name. Now, Let's Encrypt will test and make sure that only the correct instance is going to respond, because you could be in a shared hosting environment where you have, 50 domains hosted on one IP address, and whoever controls the default vhost could validate for you by chance if they didn't validate this way. That's not a big concern on the firewall because you're not going to be in that kind of a situation where you're next to somebody else untrusted, but that's just explaining why they have to require the things they require. And similar to HTTP, the TLS method must use port 443, no exceptions, so it has to be on that port. All right, the next method is my favorite one, the DNS01 validation method. Uses a TXT record in DNS to handle the challenge response, which is _Acme-challenge dot and then your host name. So the text record can be safely removed after the challenge is validated. So it can be very fleeting. It just, the record goes in automatically, then they request that record, and the content of that record is part of the challenge. So they, and then once that challenge is completed, you can delete that text record. It only has to exist for a couple of minutes a month. So it's very nice. So it doesn't require any inbound external connectivity, so there's nothing to let in through your firewall. You don't have to worry about the public being able to hit anything. It doesn't even require a publicly resolvable A or quad A record for the host name, only a text record. Like everything in my lab is set up this way. It's really the best one for firewalls and private networks and lab use, because you don't have to have inbound connectivity. Firewall talks to DNS, Let's Encrypt talks to DNS, and they can agree on that channel, but they don't have to contact you directly. So it's really nice. So you do need, like internally, when you're local to these things, you do need to be able to resolve them by hostname because you have to access them by hostname to get the benefit of using the certificate. But you don't have to have public records. You could just have entries in like a host override or something similar to that in your whatever local DNS structure you've got, whether it's on the firewall or off. So you can do these automated updates using RFC 2136, like NS update style, or there's also a variety of provider-dependent APIs we've got in the list on the package, which I'll show you the list here in a minute. And you could do manual updates even. It's slower, you can't automate it, but if none of the other things are going to work, you can do that. So you set it for a manual update, and you start the request. It tells you what to add to a DNS record. You go out there, manually add that to your provider records. Then you run it again, and they can validate it that way, and then you can delete your record once it's done. So if you want to use the DNS method and you're okay with a little bit of manual action on there, you can do that. Something you just got to remember to do once a month or so. All right, so the Acme package for pfSense is what handles the certificate management through Let's Encrypt. So it keeps all your certificate settings and everything and your account keys all in one place, and it makes it a very straightforward process. It can also automate the renewal process, so you don't have to maintain it in an ongoing manner. And it can automatically renew the certificates and restart services when the time comes if you want. And let's see where we get that. It's here under System Advanced. I'm sorry, System and Package Manager first time. And then Available Packages tab, and it'll be right there in the list. It's just Acme. Be the first. I think it's the first one on the list, just because it's alphabetically it's so high. And once you've got that installed, it's under Services, Acme Certificates, and right there. So the first thing you have to do in the Acme package is add an account key, which you can do here under Services and Acme Certificates on the Account Keys tab. Come over here and click plus to add a key. I'm going to shrink this over a little bit so I can have both of these open. So these account keys are used as part of the authentication process. So it's not a certificate, it's not the actual key in the certificate. It's a separate thing that it is used by the client to sign the entire request, or to sign parts of the challenge to prove ownership. So it's basically used for authentication, saying, okay, this is really me. I'm signing this using the key that you know that I have. And then so it's just an extra bit of authentication for that rather than part of the validation directly. So you have to have an account key, or else you can't make or sign a certificate or renew or anything like that. And your account keys are associated with either the staging server system or the production system. And again, when you're just testing this out and starting, use the staging system. Don't use the production system. I'm going to go ahead and make a key here. And I'm going to put this on the production system because I know these settings work and I've done it before. Okay, and so when it comes to the account key, you can click this Create Account Key button, and it will go off to Let's Encrypt, or actually go to generate the key, and then it'll populate this box. You could immediately click Register and then Save, but I like to click Save first, and then edit this again, just to make sure that the key is there and retained. And then once it's there and saved, then you can click Register. Then this actually goes and tells Let's Encrypt, okay, here's my key. So you don't actually have to go to Let's Encrypt and make an account or anything. This is all you have to do is just, bam, that's it. Register the key. And I just saved again. And now it's on there. You can see it's using the Let's Encrypt production. I just put GUI key, and that's fine. So next, you go to certificates. And again, you have to make the account key first. You can't skip right to this. So once that's created, you come over here to the certificates. Name, I'm just going to call this my GUI cert. And really, I'm calling it a GUI cert, but it's just because it's the only thing I intend to use on here. You could use it for anything that any service on this firewall that would be on the host name you give it. All right, status active. This is, whether or not you actually want this to be enabled or not when it comes to like automatic renewal time, that kind of thing. You could have, if you've got 5 certificates, you may want to disable one for some reason. If you did that, you set it to disabled here. Acme account, so this is your account keys that you created. If you have more than one, you just have to make sure you pick the one you want. Sorry. And then your key size. So you can do, 2048 is probably okay. Larger keys, other keys, they can be more secure, but they do take more processing power. So that's really up to you. Obviously, you can't go less than 2048, and you don't want to. But 2048 is usually sufficient. You can go for longer ones if you want. They'll just take a little bit more processing power to deal with. Now your domain SAN list, this is kind of the meat and potatoes of everything here. This is your list of names you want to include in the certificate. So you have here, oops, hold on a second. in this list are all of the different host names that are going to be a part of the certificate. So for this one, let's see, strax.lab. If I could type. And I'm going to use an NS update method here, which I'll go over more about how to use these. And and you'll see when you pick these methods, they all have different requirements. And for this NS update, you see I need a server, I need a key type, I need a key algorithm, and the actual key. So for the server, and all of these settings are going to depend on your providers or your own servers set up for these. So a lot of these you may actually have to go to whoever controls your DNS and ask them about it. And this is just going to be a temporary host anyway. I'm going to kill this after the Hangout. So let's see. Then I got my key here. And then DNS sleep down here is how long this particular firewall is going to wait between making a DNS record and then allowing Let's Encrypt to query that record. So what you have is just a certain amount of DNS propagation time that you might be up against. By default, it's 2 minutes. So you have, the client will make these records, the text record, whatever, if you're using a DNS method, or update your DNS record. And then it waits that amount of time before, and then after that time has lapsed, it will tell Let's Encrypt, okay, you can check it now. And you might need to wait, like if you've got, if your DNS structure has 2 or 3 servers and you have to wait for, you update the primary and then it updates its secondary zone and tertiary DNS servers, and it has to go through a whole DNS structure. So you may have to wait just a few moments for that to propagate out. 120 seconds is usually fine. Sometimes you may have to wait a little bit longer. Waiting shorter might be okay too if you know your servers are pretty fast. So that's all up to you. Now your actions list here, this is what will happen after the certificate is renewed automatically. I don't think this comes into play automatically when you first set up the certificate, because there's nothing for it to do really, because you haven't actually used the certificate yet because it doesn't exist. But we've got a couple of examples here, and I like to because this is going to be a GUI cert, I want to have it restart the web GUI. So you can have, again, a list of commands here, multiple commands if you want. They can be enabled or disabled. So you could, tell it, you may want to have something defined but disabled if you're not using the service at that particular time. You have a couple different methods here. You've got a shell command, restart service, or a PHP command script. Shell script, you have to put the full path to a shell command to run, including any parameters you need to pass to it. Restart service would just be the full internal service name of a service, like from status and services. And then it will restart that service. Or the PHP command script will let you just put a little bit of PHP code in that command box. Again, has to be valid PHP code, but it'll evaluate that code. So when you're getting into something like restarting the web GUI, that script, it will rewrite the web GUI configuration, rewrite the certificate, everything. And that's okay. When you just restart a service, you might need to check with that service to make sure that when you restart it, it isn't just restarting the daemon, because restarting the daemon may not be enough. It actually may have to actually rewrite the certificates or rewrite the whole configuration and then restart the service. So something to be aware of. All right, so and then the last renewal is just a field that'll show you the last time the certificate was renewed. Right now it's nothing because it hasn't been renewed before. And the renew after is how long you want it to wait before it renews. Again, the default recommended time here is 60 days, and that's just fine. You could do it a little bit earlier. I can't remember how early it is. There is a low, there is a minimum time you have to wait, but I can't remember what it is off the top of my head. But 60 days is good. Don't wait until 90 or close to 90, because if something goes wrong, you won't have much time to fix it. So 60 is best. All right, so let's save that. Oh, I forgot, I can't have space there. Okay, So I've got all my settings in there. I saved it, and now it's all there. I have to issue a renew. Now, this is going to take a couple of minutes because it's got to set up DNS records and everything else. So let's move along and we'll wait for that to finish in the background. Talk a little bit more about these individual methods that we've got in our GUI. We have several ways you can do the HTTP validation. And again, the host names in the certificate have to resolve to the firewall itself, whether it's being answered by the firewall itself or forwarded on. It's got to come through this firewall. The files have to be available to the internet at that directory that we mentioned before on each host on the host that's each host listed in the certificate. Firewall's got to allow that access into that port. So usually it's going to be port 80 on that, to the IP address that that host name resolves to. Again, has to be on port 80 from the public perspective. And some of the methods we've got here, you've got web root local folder, which it will be a file or directory on this firewall. Now, obviously, you do not want to expose your GUI to the web. You do not want to expose your firewall GUI to the internet. So do not try to use the firewall GUI for this. However, you can use it in combination with some other services, like there is a way in HAProxy to use an HAProxy update plugin, which I've got a link to on another slide here. And that can use this web root local folder. So it's okay for that, but do not use it, with the intent of letting the firewall GUI be exposed to the internet. Let's see, there's web root FTP, which copies files to another server via SFTP. So obviously you have to have a username and password to use, plus the server address and the path to the challenge files. So it has to know, what server to place it on, where to place it on that server, and then how you log into that server. Obviously, the user has to also have write permission to that target directory. So you could, use that in combination with port forwarding or one-to-one. So say you've got, port 80 on your firewall's WAN forwarded to another local web server inside. That can work just fine. Just make sure you've got an account set up for the firewall to drop those files on there, and then set up the web root FTP method. Okay, the standalone HTTP server, which is it runs a simple server on the firewall itself. The Acme package itself will set up just a basic HTTP server, and it has to use port 80. You can define it onto a different port and forward again with a NAT rule or port forward to that other port if you want. But again, the firewall's got to allow access to that. Even though the server is only run during the issue and renew process, that rule is going to have to be there all the time. Eventually, we're thinking about adding an automatic, enable disable for that rule, but it's not something we've got yet. Another thing too to look out for, if you intend to use port 80, by default, we do have our web GUI redirect on port 80 that takes traffic and forwards it to HTTPS. So you may have to disable that redirect if you want to use that method. We also have a standalone TLS, which is HTTPS server. It's technically the TLS SNI, but it's close to it, close to HTTP. Works the same as HTTP except on port 443, so it's most likely going to conflict with your GUI. So if you do that, set up an alternate listening port and port forward 443 from the outside up to that. Again, avoiding the potential GUI exposure. All right, so let's get back over here. As you can see, our request finally finished, and it looks like it succeeded. It gave me the certificate, and everything succeeded, so we're good. And if I click back to the certificates tab, the last renewed time comes up, and it's all good. All right, we'll come back to this in a minute when we talk about using that certificate for the GUI. Okay, so what we just saw was one of the DNSL1 validation methods. Again, it's great because it doesn't require inbound or public access, only DNS. So you both talk to your your external DNS servers. So great for your private systems and labs. Only has that temporary text record. No, it doesn't require the A or quad A records, but you can have them if you want them. A little bit more of a setup on the initial side as well, because you do have to either have a supported provider or an existing DNS structure. So there's the DNS manual I talked about. You manually create that text record as needed if you do it. So when you do that, you actually select DNS manual, and then you get all the way through it, and you click the issue button. It'll spin and whir for a bit, and it will actually tell you in the output, this is what you set your text record to. So then you take that, you copy that, paste that into your text record in your DNS server software or site management, whatever. And then after that's done, you try to issue it again, and it will succeed that second time, assuming your DNS was set up right. I've got DNS NS update, which I showed you. You can do the RFC 2136 style updates to your own personal bind server or a similar server that supports that protocol, as long as it supports RFC 2136 updates. It requires an update key for your text record. Again, so it's Acme underscore Acme dash challenge dot, and then your host name. And you have multiple key types and algorithms that have to match your server setup. I'm just going to pull this up so I can show you the list of what these things and what it wants. Power DNS update is similar to NS update, where it's you have to fill in the individual settings for your server, like the full URL to wherever the service is running on your server. There's a server ID, a token, and a TTL for the record. And then we have all these other providers. I'm not sure how you say that one. Ali Unix, whatever. Amazon Route 53, Cloudflare, CloudXNS, DNS Pod, GoDaddy, ISP Config, Lua DNS, DNS Made Easy, and then OVH and some other similar workalikes. So if you have one of those providers, you can just pick it from the list, see what it needs, and then look at your provider. You might have an account page or a place where you can find these values, or there may be a way to request them or enable them for your domain. So it's up to you to go to your provider and get this information. But remember, what you fill in here is the domain name. The package automatically adds that underscore acme-challenge dot to the front of that, so don't put that in your domain name here. Just put the actual host name in. So on the server side of things, if you're looking to set up your server, like a DNS server you've already got, and you want to add 2136 support to it, it's pretty simple with bind. We have a how-to up on the doc wiki, which is linked there, which shows you how to do that. It's pretty straightforward. There are a couple of adjustments you have to make versus that document. The update policy for the zone has to allow updates for TXT records or any records. You also have to have specifically defined keys for Acme underscore Acme-challenge dot hostname record, and the A and quad A records, that's up to you. You may or may not want them. And another thing to look out for too, for added security, that you can put a CAA record on your domain. Not all providers support these yet. What it does is it allows you to set a whitelist of issuers that are allowed to issue certificates for your domain. In this case, you'd want to add a CAA record that says Let's Encrypt is allowed to issue certificates for you. Now, you as a client, you're not going to be required to do this, but you can do it to enhance your security. By September 8th, issuers have to check and respect these CAA records. There are a couple of exceptions to that, like if you say, for example, try to get a cert from, I'm just throwing out there, I don't know if they do, if you get a cert from GoDaddy and GoDaddy handles your DNS, they can assume that they are allowed to do that because they are your DNS provider and they have full control of your DNS anyway. So that's a main exception. But if you don't have a CAA record, then anybody could issue a certificate for your domain, which may be okay, that may be what you want, but it's more secure. On an example record there, you have your domain name, CAA 0, and then issue, saying they're allowed to issue, and then in quotes, the domain name of the issuer, in this case, let'sencrypt.org. All right, so moving on, how do you use this for the GUI? Well, once you've made the certificate, and it shows up here, it shows your last renewed and everything, it will also have filled in the certificate manager. So there's the certificate authority from Let's Encrypt, their Acme certificate authority, and here you can see we've got our our GUI cert using the name that we put in the package, and it's got our name in it. So what we can do is go to System Advanced on the Admin Access tab, and where it says SSL certificate, we just pick the certificate, just like we would pick any other certificate, and that's that simple. Before you do that, before you actually save this, you need to make sure of a couple of things that may not be on this firewall. Number one, you need to be able to resolve this, access this firewall by host name. So you may need to add a host override to wherever provides DNS for you. That may be the firewall, that may be like an AD structure, maybe another bind server somewhere, but you need to check and make sure you can resolve this firewall using the host name that you put on the certificate. It could even be in public DNS if you want. You might, even if it's in public DNS, you might want an override so you hit the local or LAN address instead of the public address. That's all up to you though. You could still access it by IP address, but that negates the purpose of actually getting a certificate because it will warn you because it doesn't match. When you access by IP address, it doesn't match the host name. And so that won't work right. So what I like to do is I keep a bookmark for both the host name and the IP address version. I use the host name ones 99.9% of the time, but if something is broken in my DNS, I want the IP address link, so I do both. So I usually have both just to be on the safe side. All right, now once your client can resolve that host name, the new host name must be recognized by the firewall, and that can be done a couple of different ways. What I did is under system in general, I set the host name of the firewall to match what I put in DNS for it. You could have also put it here in the alternate host names in this box here, which will bypass the DNS for binding and HTTP referrer checks for that host name. So without that in there, if it's not the host name of the firewall or it's not in your alternate host names, it's going to get flagged as not being a valid domain for you to have by accessing the firewall. It's going to think, well, hey, some malicious attacker sent you a link to this firewall using a wrong host name. Why, they could be trying to do something nasty. So that's what it's designed to protect you against. So system general, set your host name or alternate host name here under system advanced, either way. And again, just setting those two, you can hit save, and in a minute that'll restart. One other note, just like I did on the certificate entry, the Acme package certificate, you should have that shell command action for restart web GUI. And so you might want to double check you've got that. Okay, well, you can see here it says invalid certificate. Oh no, continue anyway. Well, that's because I'm going by IP address. But if I do the actual host name, aha, green padlock. Come back over to Edge, actually copy that. Oh, it actually copied with HTTPS. And I got a padlock. Go to Firefox, go by host name, got a green padlock, no warnings. I think I already had a tab up here in Chrome. Voila, padlock, no warnings. So we're good. I just want to double check all those browsers and show you that it actually works in all of them. No problems whatsoever. It's just credentials there. Got to log back in because I was on a different host name before. So there we are. Now we're using our our firewall by host name with certificate. Look at the details of the certificate. Shows it's secure, and it shows everything that's used there. So it's all good. That's it. So what else could you use it for? Well, another big reason that people want this is for the HAProxy package. For sites you're hosting behind the firewall, you could do SSL offloading where all of these certificates are on the firewall. Your backend could be HTTP or a different certificate if you want. Now, for your update methods here, you could do DNS naturally because that'll work for just about anything. You could have the Acme package use like the webroot FTP method and put them on the web servers behind you with SFTP. Or you could use this the Acme update plugin and then it can run on the same port as other services handled by HAProxy. There's some instructions there, a script to download and put in I think it was a Lewis script, but it's pretty simple to just fire that up and have it uh, have it update automatically, and it will have HAProxy look and says, okay, if it's requesting this directory that is only accessed by Let's Encrypt, it will actually serve it from a local directory on the firewall where the files are placed by the Acme package. So that's pretty straightforward and pretty cool. And on your certificate entry, you will want to make sure that you have HAProxy, restarting set for that. One more thing I just remembered, I think I forgot to mention, under your Acme certificates, once you have everything working, you pop back over to the general settings tab and you can check this box here, and that will enable the cron job that checks every morning to see if the certificates need renewed. If the renewal time was over however many configured days you have ago, so in this case over 60 days, it will try to renew it automatically, and then it will run the commands automatically. But without this being active, it's not going to automatically try to do anything on your behalf. So you do need to come back and check that. So where else might you want to use these certificates? Well, your general guideline, like I sort of mentioned earlier, if you're identifying your firewall or a service on your firewall to the public, then maybe it'll work. If you're identifying to peers, probably not. So VPNs, not really. Public, sure. Captive portal, yeah, you can use it in captive portal. You could use it for the HTTPS portal or redirects. So you can enable HTTPS login in the portal. You enter in your host name, the same host name you put in the certificate. Choose the certificate from the list, and then as long as your local clients in the captive portal can resolve that host name, they'll be able to access the portal. And then for them, you definitely, I think, need to make sure that comes on the LAN interface or whatever interface they're on. So might have a little bit of a trick there with DNS, but it's not too difficult. Now for OpenVPN, no, don't do it. You always use the self-signed internal private CA cert structure. There's no benefit to trying to use a publicly trusted structure with OpenVPN. IPsec, maybe, but probably not. For mutual RSA, again, it's similar to OpenVPN. You really want your own self-generated set. But technically, it might be possible to use the Let's Encrypt to identify yourself, as long as your peer is verifying your certificate, not just that it's from the same CA. There's not really any tangible benefit there. So I would just stick with self-signed. For IKV2, like mobile clients on IKV2, you might have it's hit and miss. It may work with some clients, but Let's Encrypt doesn't allow the IKE intermediate extended key usage, and it also doesn't allow IP address SAN entries, and some clients require those. So you just got to be kind of careful with your clients. You can try it; it might work. If it doesn't, well, then you're better off using a self-signed structure. Using it with Squid, it varies quite a bit. For SquidGuard error redirects, yeah, you can use it with that. You set your redirect type to external URL found, and then you put in, a full URL like I show you here. It's got to have all those parameters on it. Just change host.example.com over to whatever the host name is for your firewall. And then, because the client is requesting that with HTTPS, then they won't get a invalid certificate prompt. They'll just get the page with padlock. For Squid Reverse, yeah, similar to HAProxy, you can do that. Although some people on the forum were talking about it's tricky to automate the reloading of that. We don't support and we don't use Squid Reverse here, so I haven't checked exactly what you might need to do for that. But if you do and you want to use that, follow up on the forum. There's some people working that out. If you're using Squid like as just a plain proxy, if you're trying to do man in the middle, no, Let's Encrypt is not going to help you there. That offers you nothing for that, because you have to have your own certificate authority, or you can't create new certificates for arbitrary sites that you need to do the impersonation that the man in the middle stuff requires. For FreeRadius and EAP in FreeRadius, maybe you may, again, it depends on what you need. Self-signed is usually better, but you can potentially use these for like 802.1x or PEEP. it really depends on your clients. Some people have reported elsewhere that clients that they couldn't import a CA into a client, and this let them work around that. But you know, it's usually again better to have your self-signed structure if you can. But this way, you wouldn't have to import or bypass any warnings for that either. For the net SNMP package, no, you wouldn't want to use this for that. It's got to be a self-generated structure because you're identifying your peers by certificates and everything like that. For NTOP-NG, it has a built-in HTTPS server, and yeah, it will automatically use the GUI certificate, and it will use it'll automatically use the Let's Encrypt certificate when you've got it set for your GUI, and it uses the host name and it works just fine. So no problems there. Now I mentioned this last month, or maybe it was the month before when I was talking about CARP or HA. Now you can use Let's Encrypt with HA. Just a couple of tricky things. You know, only install it on the primary node. Do not install it on both. Your certificate has to have hostname entries for the primary, the secondary, and the CARP VIP or multiple CARP VIPs, as long as you know whatever hostname is going to resolve to those. So you know you got to have a hostname for each node and a hostname for at least one CARP VIP. You need to use a DNS validation method because the primary unit is going to have to validate for all of these, and otherwise it couldn't validate on behalf of the secondary without if it tried to use some other method. Let's see, you also have to allow the primary to create and validate, issue the certificate, and then sync it to the secondary. So basically just create it as usual, and then if you've got XML RPC sync set up and it's handling certificates, it'll automatically copy that over. Once it's on both nodes, you set it for your GUI certificate on both, and that's it. Now the tricky part here, again, after the certificate gets renewed, the primary will synchronize that over, but the secondary will not restart the GUI automatically. So just need to be careful about that. You might have to set up like a job or something that will restart the GUI for you. We're trying to find a good way around that, but we haven't found a good way around that part yet. But that's the only real sticking point. Okay, well that's really it. One thing I didn't show you, we just a real quick brief glance at what the bind config would look like for something like this. Like first up here is your zone, pretty standard basic zone. I've just got the basic structure of it plus a CAA record. And then you have a configuration file that contains your keys. And it's just got the keys and the algorithm and then the secret key, which is what gets put into the Acme package. And in the docwiki part, docwiki document, there's a script that generates these keys for you, and it's easy to adjust it so it makes keys for these other host names too. So. And then in your main named config, you include your keys config, and then you define your zone, and it's got to be in a dynamic. It has to be in a file that bind can write dynamically. Actually, a directory that bind can write dynamically. So I put everything into a directory called dynamic and set it for where bind can create files and whatnot in there. And then I've got an update policy here that grants all those individual keys permission to update their own records in that domain and records of any type. You could have just like TXT or quad A and TXT or whatever, in a list there, but just for now, any type of key for that will work just fine. But that's just a brief look at what that might look like, but that's pretty simple. All right, somebody says intent to add support for Google domain DNS. That depends on the upstream project, the acme.sh project that we pull our code from for the backend stuff. Once they pick up support for that, we can. I just don't know. I don't know if Google Domain DNS actually has an API that will work for that yet. I know another one we're kind of working on is Namecheap. I would love to see Namecheap support. Unfortunately, Namecheap's regular dynamic DNS API does not support text records, and the API they have that does support updates is kind of really kludgy, or kludgy, whatever. You have to download the entire zone, modify a record, and then upload the entire zone again. That just sounds like a recipe for trouble to me, but it could work if we can If the provider supports it and we get code from upstream for it from the Acme SH project, then yeah, we'll support other providers as we can. All right, so go ahead and fire off your questions if you got them, or if there's anything else you want to see. I've got a few more minutes left here. If you have a longer question or something, go ahead and just type a word or two and let me know you have one coming. That way I don't cut you off early. All right, so during firmware upgrades, it is still recommended to remove installed packages prior to update, in this case the Acme package, and then reinstall after firmware update. We do generally recommend that. Removing the package won't remove the settings, and really this package only has to take action one time per month, so it's not critical to have it on there right away, so it's not going to hurt anything to remove the package, upgrade, and then reinstall the package. But in most cases, it's going to work okay, but there are cases out there where having a package installed might cause you trouble during an upgrade that you might not have otherwise. That's why we recommend that. But in this case, it's not something that's critical for you to have it on there 100% of the time. So definitely, if you think there might be a problem with the update, uninstall the packages, update, reinstall the packages. Not going to hurt anything, especially with this package. All right, anybody else? Anything else? Any questions at all about this, or even any other Hangout suggestions or anything? Let's see. So assuming Cloud DNS is supported by Certbot, would that be added later? Certbot isn't the package we use for the underlying software. It's acme.sh. Hold on a second. Let me find it. Let me look up real quick to see if they have code for that yet. Let's see. Let's say Cloud DNS. Yeah, it looks like they just added support for that, maybe about a month ago. And I don't think we've synchronized stuff up from them, but since then. But yeah, eventually next time we sync up the code with them and update the GUI to reflect that, we should pick up support for them. As far as I'm aware, I don't think there's anything holding that back anyway. Let's see. So this Hangout coverage of Behemoth router. Probably not. That's not one that I'm directly involved in. I'm not sure there's a lot to show there, especially yet. But who knows? Maybe down the road. Let's see. Any caveat if you have a different port than 443 and TumpNG? If your service is running on another port that you're using to access it, it doesn't matter. As long as the hostname portion is intact, the certificate will be fine. The GUI can be on another port, and TumpNG works just fine. The only time it has to be port 443, like I mentioned, is if you are doing that standalone TLS update and Let's Encrypt has to hit you on 443. That's the only part that 443 actually matters at all. But for your local stuff, using the certificate, you can use it on whatever port you want. And the Captive Portal would be using it on port like 8002 or something. And NTOPNG is, I can't remember what port it's on, but it's up on a high port too, and it works just fine. So it doesn't matter as long as the hostname portion is used. So as long as it's https:// your hostname : port number / whatever, and you're fine. Let's see, going back to limits of 20 certs per domain, how does that affect subdomains? Anything that's under the same domain, it's still counted against it. So it doesn't matter if you've got a.b.domain.com and a.z.domain.com, they're all considered two certs under domain.com. They have on the rate limits page, there's a link to the list that they use to decide if something is, if it has a third level component to it, like .co.uk, for example. So they don't count 20 for co.uk, they count the third level domain in that part. But other than that, they don't take subdomains into account. They only count your domain. Let's see, general hardware Hangout suggestion. Um, well, that's something we may do. I don't know how feasible that is, but I don't know. That all we'd really end up covering would be our own gear, which would be fine, but to me that wouldn't be as interesting as covering things you can do with the hardware. But yeah, we'll look into it, see if that might be something we may want to do in the future. Now, we have plenty of things that are gigabit capable. Also, it depends on if you're talking about gigabit VPN speeds or gigabit straight in the clear speeds or what. But yeah, gigabit VPN is a different animal entirely. So depends on a lot of different factors. Let's see, a couple of off-topic questions here. They say new job openings at pfSense Netgate. Not that I'm aware of at the moment, but you can always send in a resume. Let's see, if I wanted to keep two firewalls in sync but only have one physically connected, like manual failover, it's not, HA is not designed to work that way. No, you wouldn't want to do that. I mean, you're better off just keeping a backup file and then take that backup file, drop it on a USB key, and plug that in the other one and let it run the config off the USB on your cold spare. But yeah, it's trying to do a cold spare with only having one interface connected. It's not designed to work that way, and you're only going to have a bunch of trouble. I talked about that a bit, I think, in the HA Hangout I did very recently. Was it last month I did an HA Hangout? Yeah, last month. So check last month's Hangout. I had some suggestions there, but mostly I think it comes back to just use a cold spare and a regular backup. Any quick assist benchmarks for official PF hardware yet? Not yet, but that's sort of if you go back and look at the links that I put in the project notes at the beginning, the Behemoth router stuff is part of that. Part of those numbers we're using quick assist. So that's as close as we're going to get yet. Let's see, any plans for future training classes scheduled in the US? I don't know if we have any plans for doing more of those actually in person. We do lots of online training, and that's worldwide, including the United States, but sometimes unless we have a partner or somebody who says, we got some people in the city and we want to hook up and do this, and we've already got so many people in place, then that's part of the driving reason for doing these in other countries is because we had a lot of demand there. So, but we'll see. That's not something I'm over. So, as far as I'm aware, there's no plans, but you never know. Can I say anything about multi-firewall management console? Only that it's called NRDM and that we will be demoing it soon. I don't know what all the information is that's public about it yet, but during our in-person training sessions that are in the coming months, they are going to include a demo of that system and some other cool stuff. So we'll have some public info out pretty soon. So keep your ears open. All right. Well, I think that's going to be about it for now. Thank you all for attending, and we'll see you back here next month.